In a climate-controlled room at the National Institute of Standards and Technology, there is a machine the size of a small truck that can measure the distance between 2 points to within 10 billionths of a meter. It was not built by a government laboratory, or a Swiss conglomerate, or one of the Japanese giants that came to dominate the machine tool trade. It was built in the 1980s, by hand, in a fading red brick factory in Bridgeport, Connecticut, by a company that for half a century made machines more accurate than the instruments capable of checking them. The man who started that company set out to do one simple thing. He wanted to drill a hole in exactly the right place, nothing more grand than that. By the time he was finished, his machines had armed a world war, shaped the weapons of the Cold War, and helped grind the optics that looked into space. And then a thin brass wire and a few lines of computer code came along and nearly erased every bit of it. This is the story of the Moore Special Tool Company and the obsession that built it and very nearly buried it. You are watching Trade Archive. If these are the stories you came for, take a second to like this video and subscribe. Now, to understand the machine in that climate-controlled room, we have to go back to Bridgeport, decades before any of it existed. In the years around the First World War, Bridgeport was one of the loudest cities in America. Remington Arms had a plant there that needed bodies fast, and the story handed down inside the company is that they had to put 10,000 people to work in a hurry, paying 30 cents an hour to anyone who could stand at a machine. A young man named Richard Moore was one of those bodies. He started in the milling department, learning to cut metal on equipment that other men had set up. And he moved the way ambitious tradesmen moved in that era, drifting through several job shops, picking up a little more skill at each one, until he landed in the tool room at Singer, the sewing machine company, which ran one of the most demanding precision shops in the Northeast. By the accounts that survive him, Moore was born in 1896, which would have made him a man in his late 20s, with a tradesman's hands and a tradesman's frustrations, when he decided he had learned enough working for other people. In 1924, he opened his own shop. The humble birthplace of the Moore Special Tool Company sat on the second floor of a building on John Street, above a diner. He furnished it with a late-model 14-inch lathe, a milling machine, a drill, a grinder, a shaper, one toolmaker, and a boy to run errands. That was the whole company. On paper, it was just another job shop in a city full of them, taking whatever contract work the clockmakers and the brass shops would send his way. But Richard Moore had a problem he could not stop thinking about, and that problem would turn an ordinary little shop into something the entire industry would eventually measure itself against. The problem was holes. Specifically, the problem was putting a hole in a precise location in a piece of steel. Today that sounds trivial. In the 1920s, it was one of the hardest things a craftsman could be asked to do, and the way it was done was almost medieval. It was called the toolmaker's button method. A machinist would attach tiny steel cylinders, the buttons, to the surface of the work, then spend hours nudging them into position with micrometers and indicators, checking and rechecking, before he ever brought a drill anywhere near the metal. It was painstaking, it was agonizingly slow, and it leaned entirely on the feel and patience of one human being. Two skilled men could measure the same part and disagree. And in a trade that was supposed to be building the dies that stamped out millions of identical parts, that disagreement was a catastrophe waiting to happen. There was something else that made it worse. Toolmaking in that era was a guild, and the men inside it guarded their methods like sorcerers. The good ones could hold tolerances that seemed almost supernatural, and they had no intention of explaining how. Knowledge stayed locked in individual heads and went into the ground when those men died. So the industry as a whole never really got better. It just kept reproducing the same secret, fragile, human process, one apprenticeship at a time. Richard Moore looked at that and saw not magic, but waste. He believed the feel in a master's hands could be built into a machine, and that once it was, it could be repeated forever. By 1932, in the depths of the Depression, he had built the thing he had been imagining. It was a strange moment to gamble a small company's survival on a machine nobody had asked him to make, with shops closing all around him and money scarce. But Moore had decided that the only way out of the inaccuracy that plagued his work was to build his way out. He called it the #1 Moore jig borer. The reason he built it was painfully practical. He simply could not hit the tolerances the clock shops and the brass shops of the Naugatuck Valley were demanding from him on the equipment money could buy. So he built his own equipment. The heart of it was the lead screw, the long-threaded rod that moved the table beneath the cutting spindle. Other machines used soft screws and tried to correct their errors with compensating gadgets. Moore did the opposite. He hardened his screws, ground them, and then lapped them by hand, polishing away the tiny variations in the threads until the screw itself was the standard. Turn the dial, and the table moved exactly as far as the dial promised, to within a 10,000th of an inch. A job that had eaten an afternoon with the button method could now be done in minutes, and done the same way every single time. He was not the first person on Earth to build a jig borer. A Swiss firm known as SIP had been making them since around the end of the First World War, and one of their early machines, built in 1921 for a British arms factory, sits in a museum in London to this day. But the Swiss machines were laboratory instruments, fantastically expensive, locked away in the rooms of national institutions. What Moore had done was different. He had built precision that a working tool room could actually own and actually use. He had taken the sorcery out of the master's hands and bolted it to a cast iron table. There was no going back to buttons after that, and Moore knew it. The jig borer solved one half of the problem. The other half was about to make him famous. When a toolmaker bored a perfect hole into a block of steel, that block still had to be hardened in a furnace before it could survive a life of stamping out parts. And hardening steel does something cruel. It warps. It distorts. The heat treatment that made the die tough also pulled those perfectly located holes slightly out of position, and there was no good way to fix them afterward. Men would try to lap the hardened holes back into place by hand, a miserable and unreliable job that often ruined the very part they were trying to save. The most accurately bored die in the world could be destroyed by the furnace meant to finish it. In 1940, Moore answered that with the #1 Moore jig grinder. The idea was to marry the precise positioning of the jig borer to a tiny, screaming high-speed grinding spindle. Now, a shop could harden the steel first, accept the distortion, and then grind the holes to their final location and size afterward, in metal too hard for any cutter to touch. The warping problem did not have to be prevented anymore. It could simply be erased after the fact. For the men who made dies and molds, this was the difference between hoping a part survived hardening and knowing it would. And the timing could not have been more consequential, because the year Moore introduced it, the world was going back to war. When the United States entered the Second World War, the demand for precision exploded. Aircraft engines, bomb sights, artillery fuses, the early radar sets, all of it depended on parts that were interchangeable, parts that could be made by the millions by workers who had never held a tool before the war, as long as the tooling those workers used was flawless. That was the secret of the so-called arsenal of democracy. It was not that America suddenly had more master craftsmen, it was that the craft had been built into the machines. A more jig borer and a more jig grinder let a shop produce dies and gauges of guaranteed accuracy, and those dies in turn let semi-skilled hands turn out perfect parts at a speed no individual artisan could match. Moore ran his Bridgeport shop hard through those years, and when it was over, his name carried a weight in the trade that it had never had before. The factory ran shift after shift, much of its output flowing to the War Department under a secrecy that did not get discussed outside the building. And by the time the fighting stopped, a Moore jig borer or jig grinder was no longer one interesting option among several. In the top tier of American toolmaking, it had become the standard that other machines were measured against. The little second-floor shop above a diner had become a name spoken with something close to reverence. But here is where the story turns from a tale about machines into a tale about the men who built them and what that work asked of their bodies. Because a Moore machine was not really made by machines. The accuracy that everyone worshipped came from two brutal, ancient, almost monastic skills. The first was the lapping of the lead screws, that patient hand polishing of the threads that could take days to coax a single screw into near perfection. The second was harder still. It was called hand scraping. The flat surfaces that a Moore machine slid along, the ways, were not finished by any cutting tool. A man took a sharp hand scraper, leaned the weight of his body into it, and shaved microscopic flakes of cast iron off the surface, again and again, checking his progress against a master granite plate, until the metal was flatter than any machine of the day could make it. There was no shortcut, and no automating it. The skill lived in the forearms and the eyes of men who had done it for 20 years, and it was passed down the only way it had ever been passed down, one apprentice at a time, standing at the elbow of someone who already knew. It was slow. It was punishing. A man could spend the better part of a career bent over the same kind of surface, and the work took a real and lasting toll on the bodies that did it. The millionths of an inch that made the Moore name were paid for, quite literally, in human labor that most of the industry was already trying to automate away. Moore refused to. He believed the hand was still better than the machine, and for a long time, on the things that mattered most, he was right. After the war, the machines themselves kept climbing. The number 2 design arrived around 1950, heavier and better protected. Then came the machine that became the company's crown, the number 3. When Moore's engineers showed the metrology establishment how the number 3 rode on its ways, the reaction from the theorists was scorn. Kinematically unsound, they said. By the textbook rules of how a precise machine was supposed to be supported, Moore was doing it wrong. What the theorists did not yet understand was a principle the Moore men grasped by feel, the idea that many points of contact, all very slightly imperfect, would average out into something more stable and more accurate than the textbook's clean 3-point ideal. Elastic averaging, it would later be called. The number 3 was vindicated, and it became a status symbol. The company would claim that across the entire travel of the machine, a span of 11 inches by 18 inches, the positioning error stayed under 90 millionths of an inch. To own a Moore number 3 was to announce that your shop operated at the very top of the trade. This obsession led Moore somewhere unexpected. He kept building machines more accurate than the tools that were supposed to measure them, and at a certain point, that becomes a genuine problem. How do you prove your machine is accurate if nothing in the building can check it? So Moore went into the measuring business. The company built universal measuring machines, instruments whose only job was to verify the dimensions of finished parts, kept in rooms held at a steady 68 degrees Fahrenheit, because at this level of precision, the warmth of a man's hand on a steel bar is enough to throw the reading off. These measuring machines ended up in standards laboratories around the world, in the very rooms where nations kept the reference against which all other measurements were judged. It was a strange kind of authority for a private tool company in Connecticut to hold. Moore had earned it the same way he earned everything else, by refusing to accept anyone else's idea of how accurate was accurate enough. The philosophy underneath all of it was simple and ruthless, and it became the rule the whole company lived by. A machine must be built more accurately than anything it is ever asked to produce or to measure. Anything less, and the errors of the machine become the errors of the part forever. And then Richard Moore and his sons did something the rest of the trade considered close to insane. They wrote it all down. In an industry that had spent a century taking its secrets to the grave, the Moores started publishing books that explained step by step how the magic was done. In 1946, Richard's son, J. Robert Moore, put out a volume on precise hole location, the first real authoritative book on that corner of the craft. In 1954, Richard himself, with a colleague named Frederick Victory, published a second book on holes, contours, and surfaces. The two of them together would sell more than 40,000 copies. Competitors were appalled. To them, this was commercial suicide, handing the world's toolmakers the very knowledge that made a Moore shop special. Moore saw it differently. He believed that raising the whole industry would create more customers who understood why his machines were worth the price, and he was willing to be called a fool to prove it. The crown of that effort came in 1970, when Richard's other son, Wayne Moore, published Foundations of Mechanical Accuracy. It was printed by MIT Press. It ran to more than 300 pages, and it remains, more than half a century later, the closest thing the precision trade has to a sacred text. Wayne built the entire science of accuracy up from 4 ideas: geometry, standards of length, dividing the circle, and roundness. Master those 4 foundations, the book argued, and you could build anything to any tolerance the era allowed. It was translated into 7 languages and read in tool rooms and engineering schools around the world. The same family that had been mocked for giving away its secrets had instead become the people who defined the field. By the height of the Cold War, the obsession in that Bridgeport factory had become a matter of national importance. The American defense and nuclear establishment needed parts machined to tolerances that almost nothing on Earth could achieve, and the work flowed to the handful of companies that could. Years later, an executive of the company put it plainly, saying that Moore had taken the capability that was being used for the national laboratories and only later thought to sell it to anyone else. The collaborations ran deep into that world. One of the great metrologists who helped shape Moore's thinking worked at the Lawrence Radiation Laboratory on the machines that demanded accuracy beyond what their own parts could be manufactured to hold. Moore grinders, with their air-driven spindles spinning as fast as 175,000 revolutions per minute, were turned loose on the toughest aerospace alloys, the kind used in jet engines and missiles, materials that chewed up ordinary tooling. Turbine blades and fuel nozzles, the small hot parts buried deep inside an engine where a few millionths of an inch decided whether it ran clean or tore itself apart, were finished on Moore continuous path grinders because almost nothing else could hold the shape in metal that hard. The company even built machines that ruled microscopic lines onto glass, the diffraction gratings used to split light apart for science and for the first generations of laser and optical instruments, the molds that shaped early plastics, the dies that stamped the parts inside early computers, the optics that helped photograph the heavens. An astonishing share of the precise modern world traced its lineage back through holes and contours that had started life on a Moore machine in Connecticut. The instruments that came out of this era are still almost unbelievable. The measuring machine sitting at the National Standards Laboratory today, the one the size of a small truck, was one of only about 5 of its kind that Moore built in the 1980s. It uses a touch probe and laser interferometers to find points in space with a sensitivity measured in the tens of nanometers, and it lives in a room held to within 1/100th of a degree. When it was new, it was considered by many to be the finest coordinate measuring machine of its size anywhere on the planet. In 1974, the trade put the achievement into words when American Machinist magazine gave Richard Moore its highest award and reportedly described him as the man who gave the world's industry an additional decimal place of accuracy. That single line is as good a summary of the company as anyone ever wrote. He had quite literally pushed the whole of manufacturing 1 digit deeper into the small. But empires built on a single brilliant idea are fragile, and the thing that came for Moore did not look like a rival at first. It looked like a curiosity. In the late 1970s and into the 1980s, a technology called wire electrical discharge machining began to spread through the tool rooms of the world. Instead of grinding metal away, a wire EDM machine ran an electric current through a thin brass wire and used the spark to erode metal away, cutting complex shapes through fully hardened steel as if it were soft. It needed no master to run it. A programmer could load a shape, walk away, and let the machine burn the geometry overnight. For decades, the one thing only a Moore jig grinder could do was put an accurate hole or contour into hardened steel. The wire could now do much of it, automatically, for a fraction of the skill and the cost. You have to feel what that meant inside the Bridgeport factory. A Moore technician might spend weeks of his life bent over a casting, hand-scraping cast iron to a flatness measured in millionths, building one machine that represented the absolute summit of human craft. And across town, a man who had been on the job for 6 months could load a program into a wire EDM machine and produce a comparable hardened part by morning without ever learning to scrape, without ever feeling the metal under his hands. For the men who had given their backs and their hands to the craft, watching that happen carried a particular kind of weight. It was not only a market slipping away, it was a whole idea of what it meant to make something well, the idea that the human hand still belonged at the center of precision, being quietly declared obsolete by a spark and a spool of wire. As the trade later summed it up, the modern tool and die shop had wire EDM, and it produced the final geometry and hardened material in a single setup, with no grinding and no hard milling at all. The mechanical perfection that Moore had spent 50 years perfecting was being replaced by electricity and software. It was not that the Moore machines had gotten worse. It was that the world had found a way to get most of the way there without them, and the city around the factory was dying at the same time. Bridgeport had been an industrial titan, home to Remington, to Singer, to 100 smaller shops that fed the war machine and the consumer boom. Through the 1980s and into the 1990s, that base hollowed out the way it did across the American Northeast. Plants closed, jobs left. The neighborhoods that had grown up around the work began to decay. The decline of the city and the decline of the old artisanal way of making things were the same story told at 2 different scales, and the Moore Special Tool Company was caught in the middle of both. Foreign competitors, especially from Switzerland and Japan, were cutting into the high end. The wire was eating the middle. The cost of the company's hand-built, artisan-heavy way of working, the very thing that made a Moore machine, was becoming impossible to carry. The family fought. They had no choice but to adapt the very thing they had resisted for decades. And so Moore put computer controls onto its grinders, building continuous path machines that could carve shapes the wire could not touch, holding roundness to within 10 millionths of an inch and straight-line accuracy to within 50. They leaned hard on exports, with overseas orders at one point making up as much as half of all sales, which is the only reason the company survived a brutal collapse in the American machine tool market. But the pressure never let up. The Swiss and the Japanese were taking the high end with machines of their own, the wire was taking the middle, and the entire economic logic of a company that still finished its most important surfaces by hand was becoming impossible to defend on a spreadsheet. They were no longer the only road to precision. They were one option among several, fighting for every order, in a trade that had moved on from the world they had been born into. In 1994, after 70 years, the fight to stay independent ended. The Moore family sold the company. It was acquired by a longtime industrial neighbor in Bridgeport, the Producto Machine Company, and the two were folded together into a new parent organization, with the historic operation renamed the Moore Tool Company. 70 years of fierce family ownership, the obsession that had started above a diner on John Street, all of it passed into other hands. It was not a triumphant exit. It was survival, bought at the price of the independence that had defined them. And yet the knowledge did not die. Just 3 years later, in 1997, the company spun off a new venture in Keene, New Hampshire, devoted to ultra-precision diamond turning and the shaping of advanced optics, carrying the old Moore geometry into the age of nanometers, lenses, and semiconductors. The hand-scraping was mostly gone. The principle behind it was not. Wayne Moore, the son who had written the Bible of the trade, lived until 2015. He had been a remarkable man in his own right. A Yale economist, an Olympic swimmer who competed in the 1952 Games, an Army veteran of the Korean War, and the chief executive who steered the family company through its hardest decades before guiding it out the other side. When he died, in Trumbull, Connecticut, not far from the factory, the men who knew the trade spoke of him the way the trade once spoke of its greatest figures, as one of the people who had genuinely advanced what a machine could be made to do. Walk into a serious tool room anywhere in the world today, and you may still find a Moore machine, decades old, bolted to the floor, and still earning its keep. Machinists hunt them down, restore them, and trust them, because the cast iron that was hand-scraped half a century ago is still as flat as the day it left Bridgeport. The company that survives in that city now is a shadow of the wartime giant in raw size, employing dozens where it once employed hundreds, but it still does the impossible work, machining parts for aerospace and defense and medicine that almost no one else will attempt. And in that climate-controlled room at the National Standards Laboratory, the machine that started this story is still working. Still the reference against which other measurements are checked, still proving the rule that one stubborn man in a second-floor shop built his entire life around. Here is the verdict, the thing all of it finally meant. Richard Moore set out to do one small thing, to drill a hole in the right place, and in chasing that single obsession to its absolute limit, he ended up building the machines that made the tools that made the modern world. The brass wire and the computer took his monopoly. They could not take his principle. Because long after the last hand scraper laid down his tool, the rule still stands in every laboratory and every fabrication plant that pushes against the edge of the possible. To make a thing precise, you must first build something even more precise to make it with. That was the heresy Moore was mocked for, and it turned out to be the foundation everything else was standing on. If you want to see what happened to another American company that built the impossible and then watched the world move on, the next story is waiting on screen. Subscribe to Trade Archive, and we will tell it to you.